Hello and welcome back. I wanted to do a video over section 3.3 and we'll do an optional 3.8. And this is going to be solving applications of systems of equations in two equations. Okay, so one of the things that we want to do is we want to talk about some strategies for solving word problems with two unknowns. Okay, first of all, want to read the problem completely and carefully. You want to understand the problem. Okay, and I'm going to come in here and I'm going to write that. Okay, that in this part right here, we want to understand the problem and what it's asking. Okay. The second thing we want to talk about is identify primitives. And what that means is they're like formulas that you kind of already know. One is simple interest using I equals PRT, perimeter, break-even analysis, all that kind of stuff. Okay, so, look for those when they arrive. The third one is the most important one, and that's going to be define two variables, okay? And you can be creative with this, all right? Usually we use x and y, but we might be able to use something else, okay? And then what we have to do is we have to write two unique equations involving the two variables defined in section 2, okay? Oftentimes a picture or chart helps with this process, okay? And then we solve our system of linear equations algebraically. So let's take a look at this first one where it says coin total value example, all right? So our friend Scott, okay, has $6.95 in quarters and in dimes, okay? So he's got this this like jar of quarters and dimes, okay? And if you add all that money up, you get $6.95, okay? And we want to find how many dimes he has if he has 47 coins. Okay, so let's do this. Let's create two variables, all right? And so let's do this. Let's let, I already write this, let Q equal the number of quarters, okay? So we already know how much a quarter, the value of a quarter is 25 cents, but we're concerned about how many quarters there are, okay? And then on the next one, we're going to let D equal the number of dimes, okay? So we had to think about the two unknowns that we are trying to find, okay? It wants us to find how many how many dimes does he have if he has 47 coins, okay? And so, I had to come up with this, and this is the part that you have to create, okay? Q is equal to the number of quarters, D is equal to the number of dimes. All right, now what I want to do is I want to write equation 1. All right, and what I know, all right, is that if you take the number of quarters and you add it to the number of dimes, so you take all the coins and you add them up, and let's do that. If I did Q plus D, if I add all those up, it's going to give me 47 total coins. Okay, that's probably the easiest one that I can come up with. Okay, now in the second one, equation 2, it's a little bit more detailed, all right? Equation 2. Okay, now what I have is this. If I take a quarter, which is 25 cents, so if I take 25 cents and multiply it by the number of quarters, Q, okay, and if I add that to a dime, the value of a dime is 10 cents, okay, so 10 times D, okay, then that's going to give us a total of, what is it, $6.95? Okay, then that's going to equal $6.95. Okay, and let's think about this for a second. Let's draw in this right here. Okay, the reason why I'm doing 0.25 times Q is that this is going to give us the total amount, so total amount in quarters. Okay. Okay, this part over here is going to give us the total amount in dimes. Okay, and if I add all those together, then it's going to give me $6.95. So if you just kind of think about it and you're like, okay, and just think about this logically. All right, if I take 25 cents times like 3 quarters, how much money do I have? Okay, and that would be 0.75. Now I'm just thinking hypotheticals here, so I mean I'm just like, that's how I get this. But you have to use the variable and set up these equations. Okay, so now let's do this. All right, let's set up our system. Okay, and our system is going to look like this. I've got Q plus D is equal to 47. I've got 0.25 Q, whoops, plus 0.10 D is equal to $6.95. Okay, so now what I want to do is now it gets a little, you know, how do you solve this? Okay, is the question. All right, and because, you know, you can do elimination on this, you could do substitution, it doesn't really matter. I'm going to go ahead and do substitution, okay? And what I'm going to do is I'm going to take this equation here, Q plus D equals 47. I'm going to rewrite it over here as Q plus D is equal to 47. And what I'm going to do is I'm going to solve this for Q. Okay, it doesn't matter what I do. All right, but I'm going to go ahead and subtract D from both sides. And I get that Q is equal to 47 minus D. Okay, now because that's what Q is equal to, what I'm going to do is I'm going to take this and I'm going to substitute it into Q of my other equation. Okay, and so I'm going to rewrite my second equation as such. Okay, I'm going to do 0.25 times Q, but Q, remember, is equal to 47 minus D. So let's come back over here and I'm going to write that this is going to be 47 minus D, okay? And then I'm going to do the plus 0.10 D, and that's going to equal $6.95. Okay, now I need to solve this, okay? We're going to solve it just like I would. Going to distribute the 25 cents, okay? So if I take 0.25 times 47, so 0.25 times 47, that's going to give me 11.75, okay? If I take 0.25 times negative D, that's going to give me minus 0.25 D, okay? We're going to add that to 0.10 D, and that's going to equal $6.95. Okay, now I can combine my like terms, okay? So I have negative 0.25 D and 0.10 D. All right, so if I take 0.10 minus 0.25, that's going to give me negative 0.15 D. That's going to equal $6.95. And then I have 11.75 out here. Okay, now to solve for D, I'm going to go ahead and subtract both sides by 11.75. Okay, minus 11.75. All right. And so then on the next step, I'm going to get negative 0.15 D is equal to, and let's do 6.95 minus 11.75, and that's going to give me negative 4.8. Okay, now if I divide both sides by negative 0.15, divide by negative 0.15, sorry. Okay, these are going to divide out. Divide by 0.15, and this is going to give me that the number of dimes that I have is equal to 32. Okay, so now, all right, and that's what we want to know. We want to know how many dimes if he has 47 coins. So that's our answer, unless we can just write it here that we have 32 dimes. Okay, but because we're solving systems, let's go ahead and just make sure we solve for Q. So let's take this value of 32, let's plug it back into here for D, and we get that Q is equal to 47, okay, 47 minus 32. Okay, and that's going to give me, what, 15, I believe? Okay, and the number of quarters is equal to 15. All right, so that's how we would solve something like that. Okay, so it's really important. This is the most important part. Okay, you have to come up with these equations in order to solve them correctly. Okay, all right, let's take a look at this one. Okay, interest total value example. Okay, so Jim, my friend Jim, and your friend Jim invested $8,000 in two banks. Okay. B of A, Bank of America, pays 5% simple interest and Wells Fargo pays 7% simple interest. How much did he invest in each bank if he earned a total of $500 in simple interest? Okay, so first of all, we need to understand the concept of simple interest, okay, where that's I is equal to P times R times T, okay? Okay, now let's kind of think about this for a second, okay? What Jim has done is Jim has invested $8,000 into two different banks, all right? So let's come up with our variables. Let's let X equal the amount in Bank of America, okay? And let's let Y equal the amount in Wells Fargo, all right? And so what I know is this, is that if you take, let's write our equation 1, okay? And this is kind of how I always do this to write my equations, all right? If I take the amount that I invested into Bank of America, X, and add that to the amount that I invested into Wells Fargo, Y, then that's going to equal a total of $8,000. Okay, now here's where this part gets a little tricky because we didn't talk anything about the time frame of this of this thing, so we'll just consider it to be 1. So we're really just going to need the principal times the rate, all right, which is going to be 5% and 7%. So let's write out equation 2, okay? So in Bank of America, Jim can get paid 5% interest. Okay, so let's write equation 2. Okay, and remember that 5% as a decimal is 0.05. Okay, and 7% as a decimal is 0.07. Okay, now what I know is that if I take 0.05 and if I multiply that by X, the amount in Bank of America, and I add that to 0.07y, the amount in Wells Fargo, okay, that's my interest. Okay, so I'm earning 5% interest on this and 7% interest on, so 5% interest on Bank of America, 7% interest on Wells Fargo. And if I add those two numbers together, I should get a total of 500. Okay, now, okay, the equation that I want to write, my system, is this. If I take X plus Y, add that up, I get $8,000. Okay, if I take 0.05X plus 0.07Y, if I add those together, I'm going to get 500. And now it's up for us, or up to us to solve this. Okay, so I'm going to do the same kind of thing. Okay, I'm going to use substitution. I just kind of prefer substitution. And let's write this out here. And let's write X plus Y equals 8,000. Okay, if I subtract Y from both sides, I'm going to get that X is equal to 8,000 minus Y. Okay, now what I'm going to do is I'm going to take this value here and I'm going to substitute that into X of my second equation. All right, so now let's rewrite this. Let's do 0.05. Instead of writing X, I'm going to write 8,000 minus Y plus 0.07Y, and that's going to equal 500. Okay, let's go ahead and distribute this 0.05. So if I take 0.05 and multiply it by 8,000, that's going to give me 400. Okay, minus 0.05y plus 0.07y, and that's going to equal 500. Okay, now let's combine our like terms here. So negative 0.05y plus 0.07y is going to give us positive 0.02y. That's going to equal 500. Okay, and then I've got my 400 over here. I'm going to subtract off the 400 from both sides, solve for y, all right, and then that's going to give me 0.02y is equal to 100. Okay, so now what I want to do is I'm going to take, let's go ahead and divide both sides by 0.02, divide by 0.02. Okay, these divide out, and we're going to get 100 divided by 0.02, which is going to give us $5,000. So y is equal to $5,000. All right. Now, the question is what's x? Okay, and we have an equation already written for x. All right, which is over here. X is equal to 8,000 minus y. So if I wanted to solve for x, okay, I would just do 8,000 minus 5,000, which was what y was. Okay, plug this back in up here. So then we get that x is equal to $3,000. Okay, and that's what that is. All right, so there's that one. Okay, now let's talk about a mixture example. These questions are kind of tricky. Okay, so on these mixture problems, these are pretty tricky. So it's really important that you guys kind of pay attention to what I do here. Let me zoom in on this. Okay, and let's read it. Okay, so what it says is that an alcohol solution is 25% alcohol. A different solution from another manufacturer is 65% alcohol. A doctor wants to combine both solutions to make an 8-liter mixture, which is a combined 40% alcohol. How much of each solution should she use? Okay, so let's kind of think in context here. Let's think about coffee. All right, let me do this down here so you guys have some room to write. Okay, let's think of coffee. Have you ever made like weak coffee? All right, so if you have like weak coffee, all right, where it's not very concentrated, like the amount of coffee that's in your cup isn't very good. It's like a light brown, it's not very good. And then let's say that your like neighbor at work has like exceptionally strong coffee. So then if you add like really strong coffee, okay, then you have to think about what do you get as a result, okay? And coffee is something that we all kind of drink, hopefully, and if not, that's okay too. But if you add weak coffee and really strong coffee, you're going to get normal coffee, okay? I had this issue one time, just as a side story. I decided, you know, my grandma, whenever she makes tea, she uses the tea bag twice. And my mom thinks that she's crazy. And I'm like, well, it makes sense. I'm sure there's enough tea in there to make another cup of tea. And so when I made coffee one day, I decided to not throw the grounds out. I wanted to test this out. And so I made another like pot of coffee with the grounds that I had already used. And so I got like really weak coffee. And I tasted it and I had put like my creamer in it and it was like water, okay, with creamer. And so I poured like half of it out and I went to my neighbor and I said, hey, and this is at work, and he would always make like the strongest cup of coffee. And so I'm like, hey, can I get like half a cup of coffee from your coffee pot? And he was like, sure. And when I combined the two, I actually got normal tasting coffee, okay? And that's exactly what we're doing up here, okay? It's just that we're dealing with a different type of solution. Okay, we're dealing with what we call an alcohol solution. So, so you have an alcohol solution. First of all, it's 25% alcohol, all right? And I'm going to write that down over here, okay? I have 25% alcohol. We're going to call that X, okay? And this is X liters of solution, of the solution, okay? All right, of 25% alcohol. Okay, we also have 65% alcohol, and we're going to call that Y, okay? And this is going to be liters of solution, okay? Now, what I want to do is I want to combine, in my first equation, I want to add this number of liters of solution of 25% alcohol to the other Y liters of solution of 65% alcohol, and I want to get 8 liters, okay? So let's do that, all right? So if I do, so So equation 1 is going to give us x plus y is equal to 8. Okay, that's the first equation. Now the second equation is where this gets a little tricky. So what I want to get, all right, is I want to take 25%, and let's write this in equation 2, okay? Remember, 25% as a number is 0.25, okay? 65% as a number is going to be 0.65. All right, so if I take 0.25x plus 0.65y, it's going to equal 40% solution. Okay, now remember 40%, all right, a 40% solution is 0.4. Okay, so that's going to give me 0.4 times 8 liters. Okay, and that's where it gets really, really, really tricky. Okay, is that this is the amount of 25% solution. This is the amount of 65% solution. When you combine them, your desired amount is a 40% solution of your 8 liters, which is kind of interesting. But they're all going to go like this, okay? So now, let's write out, and where do we have room at? Let's write it out over here. Okay, if I have x plus y is equal to 8, and if I have 0.25x plus 0.65y, that's going to give me 0.48. Okay, so now what I want to do, I just like substitution, so I'm going to rewrite this equation over here. I'm going to do x plus y is equal to 8. All right, I'm going to go ahead and subtract y from both sides. So I'm going to get x is equal to 8 minus y. All right, now I want to take this again and substitute it in for x of my other equation. Okay, and so I'm going to do 0.25 times x, but x is going to be 8 minus y, okay? And then I'm going to add that to 0.65y, and that's going to equal 0.4 times 8. Let's go ahead and do that math. 0.4 times 8 is going to give me 3.2. Okay, so I'm going to do 3.2 here. Okay, I'm going to distribute my 0.25 here. So 0.25 times 8 is going to give me 2. So I've got 2 minus 0.25y after I distribute that 0.25 into the y, and then add that to 0.65y, and that's going to equal 3.2. Okay, so if I take 6.5 or 0.65 and subtract off 0.25, that's going to give me 0.4y. So combine these like terms, that's going to give me 0.4y is equal to 3.2. And then I'm going to do 2 plus that. Okay, so let's go ahead and subtract off the 2 from both sides. And so then I get 0.4y is equal to 1.2. Now if I divide both sides by 0.4 by 0.4, okay, y, 1.2 divided by 0.4 is going to give me y is equal to 3. And that's liters. Okay, so now, all right, I'm going to go back up here. I'm going to solve for x, okay? And so then I'm going to plug this back in for y up here. X is going to equal 8 minus 5, or I'm sorry, 8 minus 3, that's my bad. 8 minus 3, so x is equal to 5 liters, okay? So once you guys get down, I mean, I know these numbers are kind of hard to work with, but once you guys once you guys get down to these, numbers here, all you're doing is the same thing you've done in the last 2 sections. Okay, the hard part is setting these up. Now, these are all pretty standard. This mixture one's pretty tricky, okay, especially this 0.4 times 8 business. Okay, so that's always going to come into play with a mixture problem. Okay, so on this page, we just got a couple more problems to do. Let's look at a geometry example, and what it says is the perimeter of a rectangular oceanfront lot is 190 meters. The width is 1/4 of the length. Find the dimensions. Okay, so first of all, we have a perimeter of a rectangular oceanfront lot. Okay, so let's write out, let's draw a rectangle. Okay, And I'm going to call this this length here my width, and this my length. Okay, so this is my width right here. Call that W, and call this one length. Now, because we have a rectangle, this is also my length, and this is also my width. Okay, and it says the perimeter of this rectangular oceanfront lot is 190 meters. So if I take W plus W plus L plus L, if I add all those up, it's going to give me 190 meters. Okay, now if I combine my like terms here, W plus W is 2W plus 2 L's is going to give me 190 meters. Okay, this is equation 1. Okay, now what I want to do is talk about the length and the width. Now they give us this statement here, and the statement says that the width is 1/4 of the length. Okay, so what I want to do is write out an equation like this. Okay, and I would say that my width is equal to 1/4 times the length. Okay, and you kind of have to just think intuitively about this, because sometimes writing these equations based off of what it says here is kind of difficult. Okay, and so if the width is 1/4 of the length, let's say that the length is 4. Well, 1/4 of that would be 1. That would be the width. Okay, so if I plugged in 4 into here, multiplied it by 1/4, that would give me 1. Okay, so this is correct. Okay, this is equation 2. All right. Now, what I have with this, okay, with this equation 1 and equation 2, is we have our system. So I'm going to write this out, and I'm going to do 2W plus 2L is equal to 190. And I also have that W, and let me write that here, W is equal to 1/4 the length. Now what I'm going to do, because I've already solved for W, this one's nice and easy to do with substitution, but I'm going to plug this value in for W here. And I'm going to rewrite my first equation, 2 times W, but I don't want to write W, I'm going to write what W is equal to, which is going to be 1/4 times the length. Okay, and then I'm going to add 2 times the length, and that's going to equal 190. Okay, so let's go ahead and solve for L. And here's what I've got. So I've got 2 times 1/4. Okay, so if I take 2, and to do this, I'd want to do 2 over 1 times 1 over 4 times the length, plus 2L is equal to 190. Okay, to simplify this, if I want to do 2 over 1 times 1 over 4, I'm going to multiply straight across. All right, and so I'm going to get 2 times 1, which is 2, over 1 times 4, which is 4, times my length, plus 2L is going to equal 190. Whoops. 190. All right, so now 2 over 4, this simplifies to 1 over 2. Okay, so let's rewrite this as 1/2 times your length plus 2L is equal to 190. All right, now this is where it gets a little tricky, and let's rewrite this up here. I want to combine these two as like terms. Okay, now I know it's going to give me 2.5, so 2.5L, okay, is equal to 190. Okay, now if you didn't, sometimes it's not as easy to do these fractions, so you'd want to combine these two, and so you would end up doing, if you wanted to keep it in fraction mode, do 1/2 plus 2 over 1. So that's going to be a common denominator of 2. So it would give us 1/2 plus 4/2, which would give us a total of 5/2. Okay, same thing as 2.5. Okay, but let's just go ahead and divide by 2.5 here and by 2.5. And so our length would be equal to 190 divided by 2.5. So 190 divided by 2.5, and that's going to give me 76. And this is going to be meters. All right, so now remember, all right, all we have to do now is take this value here, L equals 76 meters, and plug this back in to here to find W. So W would equal 1/4 times 76. Now multiplying by a fourth is the same thing as dividing by 4. So I'm going to do 76, I'm going to rewrite this as 76 over 4, and that's going to divide out, and we're going to get 19 meters, okay? So my dimensions, okay, when I write my answer, my dimensions are going to be 19 by, what was that, 76? 76. Okay, and that's going to be in meters. All right, that's what I got for that. All right, the next one we've got is called the break-even analysis example. So a business's total cost can be described using the function c of x is equal to 15x plus 3100, and its total revenue can be described as using the function r of x is equal to 40x. Now, what I know is this, okay? When you're talking about, cost and revenue, what do those mean? Okay, so cost, okay, is money spent, okay? Cost is equal to money spent, okay? Revenue, okay, is equal to money made, all right? And so, if you guys ever start a business or do anything like that, it's going to cost you money to start that, but then you want to make sure that you're making enough money in revenue that your revenue outweighs your cost, okay? So what I have here is something called profit, okay? And profit is what's left over if you take your revenue minus your cost. Okay, so in part A, if it wants us to write a function that describes the business profit, then what we would do is we would take P of X, which is equal to R of X minus C of X, okay? Now, R of X is 15 plus 3100, so my profit, P of X, is going to be 15X plus 3100 minus, okay, 40, or wait, I've done this backwards. Let's redo this. My apologies. Okay, so let's redo that. My revenue, is going to be 40x, and then minus the quantity, 15x plus 3100. Okay, so I'm going to subtract those two, and so my profit, P of x, is going to be equal to 40x minus 15x, which is going to give me 25x, and then distribute your negative, and you're going to get minus 3100 out of that. All right, so there's your profit function. That's for part A. But what we're really concerned about is determine the break-even point. And the break-even point is when you've made enough money to outweigh your cost. Okay, so break-even point in part B means that your cost, C of x, is equal to the amount of revenue that you've made, R of x. Okay, and so what I want to do is just set these two equal to each other. And we've got 15x plus 3100 is equal to 40x. And I want to solve this for x, so I'm going to go ahead and subtract 15x from both sides. Okay, so minus 15x. Those cancel out, and so we end up getting 3100 is equal to 25x. Divide by 25, divide by 25. And so if we do 3100 divided by 25, it's going to give me that x is equal to 124. Okay, so now what I have, and that's it. That's the break-even point. Normally, you know, x would be like the number of units sold or stuff like that. I like to think, you know, on these problems of like a lawn mowing business, okay, think about your cost for a lawn mowing business. Okay, you have to buy the lawnmower. You got to pay for gas. Then, when you mow lawns, you want to make sure that you're making more money to help pay off this cost, okay? When you get into like significant like business analysis, these things are very, very complicated because you're dealing with a lot of different things, but you know, that's just kind of it. So hopefully you enjoyed this video. Just go ahead, guys, and let's do 3.3 for right now. 3.8 is optional for right now. We're not going to do it, but that may change in the future. So I will let you know personally in class if that is something that I want you to do. So hope you enjoyed it, and we'll see you soon. Thanks a lot. Bye.